How are you, everybody who's watching this video? My name is Olenjolai single from the beautiful, fantastic country, United Republic of Tanzania. I'm very glad to welcome you today onto our online schools. That's called the Tanzania Online Ordinary Secondary Schools in square bracket Olenjolai. Simultaneously, I would like also to welcome into our official YouTube channel. That's called the Tanzania Online O-Level. So there's a dash here, O-Level, Seki School. In square bracket Olenjolai. Seki is abbreviation of secondary. So schools in square bracket Olenjolai. Well, in these schools we have a vision, and these visions come from the Lord or come from God. And the vision in this one that the Lord has been revealing in my mind for a long time before I began this program, right? He has been saying that, my son Olenjolai, you know why did I bring you onto this planet Earth? One of the purpose that made me to bring you, I want you to be a part of the teachers, or it means that God wants me to be a part of the teachers or trainees who will be training or teaching students in the classroom instructions, and combine that classroom instructions in both mathematics, in science subjects, means physics, chemistry, biology, and agriculture, and combine with the knowledge and wisdom of the Word of God in order to solve real life problems. So in the community, in our communities, we have problems, and even some of the problems are very smaller. They don't need even to a great knowledge for somebody to have a PhD. It means just need the basic knowledge of the science of nature or simple mathematics, like the ordinary mathematics. So that's why that we'll be incubating students and preparing their minds, whether they are continuing students or after they graduate in ordinary secondary educations. But our intentions, we want to see them so at least they solve even a single problem before they shift into advanced level or into the ordinary diploma. So for that case, now we have some departments in these schools. We have 3 departments currently, but there are some other departments that will be added on top of these 3. The first one is physics, where we're teaching 4 subjects in physics: physics form 1, physics form 2, physics form 4, physics form 3. So we are teaching 4 classes, the subject of physics. Actually, myself, I call it basic physics, but according to the curriculums, they call it just physics, okay? General physics. And then we have departments of basic mathematics. We are also teaching 4 subjects. We have departments of chemistry. We are also teaching 4 subjects from Form 1 to Form 4. So actually, this is an ordinary secondary school, which actually every student in Form 1, Form 2, Form 3, Form 4 will benefit in 3 subjects. So today we have a subject called physics, and this contents is for the Form 2 or Class 10. Some of the countries they call it Class 10. So, and then the main topic that we are going to learn today is called motion in a straight line, okay? And then this is session 2. This is session 2, or lecture 2, or period 2. So this is session 2, okay? This is session 2, or period 2. And the good news about this session, we have some demonstration, meaning that, yes, I will show you some of the phenomena by using the physical devices, or physical electronics equipments, electrical and acoustic equipments. Okay, so let us go direct to them. You have to make sure that we have also a special video that giving you introduction, what problems are we solving, how can you register, how can you stay connected in these programs, how can you receive hundreds of videos. So you have to make sure that you go into these YouTube channels of Tanzania Online O-Level Seti School in square bracket Olenjolai, and search for the video has been written, session 00, general introductions of the Form 2, general introduction of physics Form 2. So you get too much details concerning about the big picture of physics, what are the topics for the Form 2. So we'll be happy if you go through them, so that now we can go directly into today's session, or into the contents that I've prepared. Before I begin these sessions, I'll just remind you that in the general introductions, I explained you to have students to have at least some of the reference books, and one of the reference books is this book that has been written as physics syllabus for ordinary secondary education for Form 1 to Form 4. In case you don't have it, you can order a copy of this book or the book itself if it's available. There's a scarcity of these books from the Tanzania Institute of Education, or TAYAI, but you can have a copy of it. So you can order, just go to the description of this video, and then so you can see how much does it cost you and what the shipping cost is. So you can ship in all the regions, 31 regions of United Republic of Tanzania. Again, so you have questions and answers book. This is the one of the sample that's Form 2 Physics Review, Problems and Solutions from 2003 to 2019. So this book comprises all the questions from all the nectar questions for the Form 2, not for the Form 4. Again, I insisted you to have a reference book. So, for example, that I just want to remind you should have this book beside you. It's Physics Form 1, Form 2 students' book. It has been prepared by Tanzania Institute of Education. So those are some of the contents. You should have an exercise book because you are very serious in this program. Even this one, this is in Sungura, okay, Umsomi, or any kinds of exercise book that you may have. Okay, you should have a pen, you should be concentrating, and you have to listen and watch these videos several times until the concept that has been taught you will click in your mind. So in session 00 or 01, it means that in session 00, for instance, let me just give a quick review. In session 00, which is a general, which is called, first of all, General Introduction of Physics Form 2. Okay. So in this one, first of all, I've declared the vision, okay, the visions of this program, and then I declare the problem, statement, and solution. What problems are we solving? I'm solving a problem that I should solve before I leave into the cemetery, okay? I have to pour out myself. And then I shared with you about big picture of physics. There's a big picture in my mind concerned about physics. And then I shared to you about reference books. And these reference books and material, okay, reference books and materials, I classified them into two branches, right? And the first branch is what? So the first branch, we say that we have textbook, right? Textbook. And then second branch, you have question and answers books, okay? So that's what I shared. And then finally, I mentioned all the topics, right? Topics of 40 of Form 2, Physics Form 2, right? Physics Form 2. So in case you want to get too much details, just to go into this video. In session 01, in session 01, I gave you kinds of the general introductions. I just repeated what, in some circumstances, what I've said, but also I've mentioned about the specific objective, right? First of all, the subtopics of this topic, right? There are subtopics for the motion in a straight line or motion in a straight lines. And then I mentioned again what I presented to you about specific objective, and I left you some blanks. Specific objective for students to fill because we want active students. So we have spoken so many details. So you have to make sure that you go through them. So today we have session 2, and this is titled as Types of 40 of Motion. So that's the center of the today's session. So get prepared to receive informations which are very important for the rest of your life. Are you ready? You love physics? Okay, I do that. Tell me in the comment sections. Use the comment section to ask a question and even to get in touch with me. So the fundamental question for Sir Olenjolai, once we teach you any new concept, okay, remember that I used to teach in English and Swahili only the Form 1 subjects. So for the 3 subjects, basic physics, basic mathematics, physics, and chemistry for the Form 1, I teach them by using 2 languages, English and Swahili. But for the Form 2, I teach them by using English because I believe that now every student of mine has been transformed into learn by using English. Because, for example, in basic mathematics from 1, I taught you 11 chapters. So you have been listened because I used to teach in English, I write everything in English, but I translate in Swahili. So what is motion, first of all? Before we go for the types, before we discuss about displacement, about distance, about velocity, about speed, about velocity time graph, about acceleration or deceleration, what does it mean about the word motion? But what is motion? So you can pause the video and then write yourself, because motion is not a new term. Yeah, you heard it, okay? We call it just like mwendo kasi or whatever. I call it just like mwendo kasi, okay, in Swahili during your primary education. So you heard it. So what do you understand when you hear about motion? Motion. Rest. Motion. So motion means something is moving, or an object is moving. Resting, an object or a body is standing. Right? That's what has to come in your mind. So I found two definitions which are very important. You may choose one of them. Okay, say that in physics, motion is a phenomena. Motion is a phenomena. Okay, motion is a phenomenon. Okay, this motion is a phenomenon in which an object changes its position, okay, over time. Changes its position over time. Okay? Or some of the reference you find is, or in physics, the motion is a change. A change in position. A change in position, okay, of an object. Of an object with respect to its surrounding. In a given interval of time. Okay? Given interval of time. At the full stop. So let me explain these two definitions which are written, which defining the terminology or the vocabulary that's called motion. What's motion? In physics, motion is a phenomenon, right? This is the phenomenon, it means that it is a term in which object changes its position. So the object is the one that changes its position, right? It's what? Its position. Okay, its position over time. So if, for example, I am an object, right? Then I change my positions over a certain time. For example, this is my first position. Then I want to move to here. So I've changed the position over a certain interval of time, right? Or again, suppose that this is my initial point. Then this is my position. So I want to change the positions. I want to go back. So if I move back like this way, I've changed the positions over a certain interval 40 of time, which is measurable, whether in seconds, whether in microseconds, whether in milliseconds. So it depends. Again, the second definition in physics, we define motion as a change in position of an object with respect to its surrounding, right? With respect to its surrounding in a given interval of time. So you see that in both definitions, term time play a great change or a great interval of time. So this is R. Okay? So interval of time. So the word time is common in both definitions. Okay, in a given interval 40 of time. So it's a change in position of an object with respect to the surroundings. That sometimes, what does it mean? The surrounding can affect motion. For example, if the surface is rough, then we have frictional force. So that frictional force can reduce the motion of the body or can accelerate the motion of the body. Again, for example, that if the surface is smooth, so the smooth surface also, it can either affect the motions at all, or it can accelerate motions if that object should move or can have a capability to move in the slidings or in the smooth surface, but over interval of time. So what means of interval of time, for example, if I moved it from point A to point B, and then I spend, let's say, 1 second, that means of interval of time. So it means I began my journey maybe 20 minutes past 20 minutes past 4. Then I arrived at 20 B, 20 minutes past 4, but with 1 second, with addition of 1 second. So that the meaning of 40, and the meaning of 40. So this is the one of the fundamental question number 1. And the meanings of interval of time. So it's a change in time. Again, the second question, after defining now, which come in your mind, once that you are learning stuff sequentially, okay, what are the examples? What are the examples? What are the examples of 40 of motion? Because if you really catch up the definition, then you can understand the term. So examples, because these examples might be a real life phenomena or real life processes which are easy for you to understand, because even yourself, you are performing them every day, whether you know or you don't know, right? So stop the video, take a piece of paper or rough paper, and write some examples of motions you know. Write some examples of motion you know, and then click the buttons of continue of play to continue watching and to analyze your examples with examples that I'm going to give or to mention before you, right? So these are the sum of the examples. So you say that the motion of the student, whether a boy, right, from what? From home to what? To school, to secondary school. Okay, secondary school. So I can say that the motions of a Form 2 student from home to what? To secondary school, and even sometimes even returning back home. So that the example 40 of motion, right? But again, we can experience that it can be either on foot, or it can be by using a bicycle, can be by using a school bus, can be by using private car. It can be, so you see that there are different, we call them vehicles which can take you from one place to another place. But again, we say that, for example, second example, we say that it's a travel. So we say that the motion of the car, the motion of a bus, let's say, right? From where? From Dar es Salaam, right? From Dar es Salaam, for example, Shabibi, Dar es Salaam, right? To what? To Dodoma. Dodoma is headquarters of United Republic of Tanzania. So that is an example 40 of a motion. So when you see cars or buses passing along the roads, right? Okay, opposing each other. This is going this way, this is going this way. So you, as a Form 2 students, you have to think that this is experimentations or applications or demonstrations of what? Of motion. Then we have the third example. Okay? The third example, for instance, that we say motion of the boat. We want to cross the Indian Ocean, right? So we say that motion of a boat, right? Motion of a boat. And this motion of the boat from where? Motion of a boat from Dar es Salaam, from Tanga to Pemba. So across the Indian Ocean. If you want to go to Pemba, or you want to go to Unguja, or you want to go to Zanzibar, because Zanzibar is one of the islands of, yes, Zanzibar comprises Pemba and Unguja. So then you have to take a boat. So that movements of the boat is example 40 of motion. Again, we say that the motion of, we call it in Tanzania airline, okay, of Tanzania airline, okay, or we call it in Fast Jet Airlines or Fast Jet, right? From where? From Mwanza to bear. So this is the example 40 of motion. Can you tell me the fifth example of any kinds of the motion? Again, in geography during the form one, we learned about the motion of what? Motion of the S revolving the sun, right? The sun in the solar system. In the solar system. And we say that the S revolves the sun for how long? In the solar system. For how long? For 365 days. Okay? That's another example. So even the S are revolving around the sun in the solar system is an example of motion. So you see, so in geography you're learning motions, in physics you're learning motions, in chemistry you're learning motions. You see? So that's all. Then number 6, we have against another type of motion. We say that flowing of the water, right, in the river. So, for example, in Tanzania we have some big rivers, for example, Ruvu, or for example, that we have Wami River. So, movement of water in flowing of the water from the source of the river to the oceans or to the sea or the Indian Oceans. Also that type of motion, that type of movement or change of positions over time, we call it for water, we call it motions. And in physics, when you pursue your programs or when you go for advanced education, you will find a special topic that's called fluid mechanics, dealing with movement of water from one point to another point. Also, when you take a route of ordinary diploma in physics, it means that in engineering or science courses, then in physics you learn a topic or a subject or modules or a course that called the fluid mechanics, and it's very interesting because you'll be learning some of Bernoulli's principles, Poiseuille's principles. So there are so many informations which are very interesting, and you get surprised because myself, when I was young, I grew up near the river, and that river is called the River Ngerengere, which actually are crossing the regions of Morogoro, Pwani, Dar es Salaam, and then to the Indian Oceans. So it was very interesting river, and I was actually examining when it is overflowing, or there's a floods, because there's floods sometimes, and even you find that the water are passing or are even just flowing outside the banks of the river. So it was very interesting. I came to understand when I was learning about fluid mechanics. So I gave even just a promise. Make sure that you pass physics, you love physics, and you have to make sure that you study physics for the rest of your life. You'll understand many life phenomena that you see, and you ask many questions yourself, and you don't understand. Okay, so those are the 6 examples. You can have even more than 6 examples. Okay, so let me give you number 7, because of how many days in the week is 7 days. So 7 days. So let me give the 7th example. The 7th example, I would like just to bring you into the domestic. We say that the motion of the fan blade, right? Fan blade. When the fan is cooling what? It's cooling air. It's cooling air. So that's another example. The motion of the fan when the fan is cooling air, and I have a sample of the fan. This is one of my fan. So you see that. So this is the motion. So for example, that if you're connecting to electricity, you find that this fan blade is rotating. So when it's rotating, that's types of motions which we call it rotational motion, right? Because there's an axis of rotations, which I will tell you at one, because that's one of the example 40, one of example of rotational motions. Because you said that you're going to learn about types of motions. Okay? So, for instance, if you have a fan, see? So now the fan is revolving, right? So you see? So this is the type of the motion. Interesting. You love physics? So it's revolving, and then it's making an angle, and then it's just returning back. Okay? So the fence is just moving this way. Very interesting. This is the type of the motion. So at homes, we have several electrical equipments and even mechanical equipments that are exhibiting motion. So this is the motion. So these are the two types of motion. So even itself is rotating. It's first of all rotating, but also it's describing a circular which is semicircle, right? Because this just, you see now, it means that it's going back. So that's a semicircle. It's just rotating, or it's just describing a cycle in 120 degrees. So that's an example 40 of motion. Okay? Another example of motion. Interesting. I think that is interesting. That's a beauty of physics. So now, allow me, so you can even mention some other examples. Allow me now to teach you about types of 40 of motion in physics. Right? Types of motion in physics. We have also many types of motions in chemistry and some other subjects. But our focus here is in one of the branch of science that's called the physics. Right? Good. So we say that we have so many. So we say that in physics, there are so many types. Okay? Types of motion, right? But there are, okay, so of motion. That's the first sentence I want to make. Okay? In those so many types of motion, we say that, but there are three basic types of 40 of motion, right, in physics. And that is our discussion. There are three basic types of 40 of motion in physics. There are three basic types of 40 of motion in physics. Not 4, not 5, not 6. Okay? And these types of motion are, the first one is called the translation motion. Say translation motion. Or we call it rectilinear. The second ones, we call it circular. But let us call it rotational motion. Rotational motion. So it's rotational motion. And then the third type of motion, basic type of motion, basic type of motion, this is called the number 3. Okay? Number 3, this is called the oscillator. We call it oscillatory, say oscillator. Say oscillator. Oscillatory motion. Oscillatory motion. So you have those 3 types of 40 of motion in physics. 3 basic types of motions in physics. And allow me to discuss or to teach you each type of this basic motion before even we go far. Okay? Let us begin with the first type, which is called the translation. Say translation. Say translation motion. Say translation motion. Say translation motion. What is translation motion? What comes in your mind when you hear about translation motion? Translation motion. Translation motion. Translation motion. Okay? So we have a fundamental question. This might be question 3. Okay? What is translation motion? What is translation motion? What is translation motion? That's the question. And also you have this translation motion, you can call it translation, so you can call it rectilinear motion. So you can call it translation motion or rectilinear motion. So this is a translation motion. Translation motion, we say that the motion in which all points of a moving body move uniformly, right? Uniformly in the same line. Okay? Or some of the reference books define translation motion as either one-dimensional. We have one-dimensional motion, we have two-dimensional motion, we have three-dimensional motion, right? Dimensional motion along a straight line. Along a straight line, and they can therefore be described mathematically using only one spatial dimension. Described mathematically using spatial, using only one spatial dimension. Okay, so we've explained these two definitions, the sentences that are written here. So let me explain it slowly. We say we have how many types of motion? 3. How many? 3. The first one, translation motion. Second one, rotational motion. Third one, oscillatory motion. Right? Oscillatory motion. The second one is rotational motion. And the first one is translation motion. Right? And we began with translation motion because we are familiar with these types of motion. Even during our primary education, we learned it in Swahili language. For those who are watching this video who are Tanzania. We say that translation motion is a motion in which all points of a moving body, of that body that changes its position, move uniformly in the same line. For example, that this is the body, right? This is the body. Listen carefully. This is the body. Spread at point A here. And then I move to point B, right? All the particles of this ruler have been moving in the same straight line and uniform. None of the particle which has been remaining back while the other are moving forward. So when you say that all its particles, all points of a moving, it means that these are the atoms that composing this ruler, because you know that an atom is the smallest part of a matter, right? So all points moving of a moving body move uniformly in the same line. So in the same line. So for instance, myself, I have my hands. So my body contains hands, contains legs, contains heads, contains ears, contains skins. So if I've been moving from this point A to point B in a straight line, that's what we call the translational motion. So the directions of the translation motion is a straight line. So if there is a corner, then there against we don't have a translation motion. So you have kinds of the circular motions, which is another type of motion. So it means that translation motion, this is the motion whereby all the particles of the body move in a straight line. So it's a motion in a straight line. That is. The second definition, we say that against this translation motion, it's a one dimension. One dimension means that, for example, an airplane, it does not describe this type of motions unless it's in the resting state, or yes, because there is a takeoff, there is a landing, and also there is a resting, or we call it a comfortable place. So it's a one-dimensional motion along a straight line. So you see again that it means that this is the directions or even the path should be a straight line, right? And can therefore be described mathematically only, okay, by using only one spatial dimension. So it's one dimension. When you say one dimension, what does it mean? We taught you the topic you call the coordinate geometry, for example, during the Form 1 in mathematics. So in coordinate geometry, we had XY plane. So XY, for instance, in coordinate geometry, XY is one dimension. Y is another dimension. So if you have XY plane, that is two-dimensional, right? So it has a horizontal dimension and vertical dimension. So for this straight line, it might be either horizontal directions without a vertical directions like this, or vertical directions but in straight lines like this. So also this is a translation. If the body is moving from bottom to the top, or from top to the bottom, right? Similarly, if I move horizontally in a straight line, this we call the translation motion. So it's a one dimension. It's either horizontal motion or vertical motion in a straight line by the means of one dimension. Some of the system or some of the vehicles, okay, or some of the bodies, they moves in three-dimensional. For example, a gas molecules move in three-dimensional, right? Also, for example, also an airplanes, or for example, a bullet fired by the gun, move in two-dimensional, which is XY, right? While a gas is moving in three-dimensional, which is X, Y, in X-axis, in Y-axis, and Z-axis, right? So motion in straight line is not the topic we are learning right now. So we'll be guiding ourselves to learn everything in a straight line. You like the straight line? Okay. So what are the examples? So if you refer previous examples, okay, from example 2. So examples of what of translation motion. Refer example 1 to example 5. Okay. Refer. So examples of what of translation motion. Translation motion. Okay. Previous example 1 to example 5. So those are examples of what I'm avoiding as a redundancy. Repetition, so I've already taught you. Example 7 and example 6, we are not in translation motion. Right? If you have any question, don't hesitate to ask in the comment section. Let's go to the second type of motion. So we'll be focusing into this translation motion. But I want just to give you the overview for rotational and the oscillatory motions, because we find them in our daily life, but you have to get prepared to enjoy them when you go to the next level, that either advanced level or ordinary diploma level in engineering or science. Okay, rotation motion. Advanced level, if you go advanced level and you study advanced physics, we find there's a topic in mechanics called rotation motion. It's a topic. And that topic is almost the weight of that topic is almost like 4 topics of the O level, of the Form 2. So if you take the first topic of Form 2 to the first topic, you combine them, you get one topic, the weight of one topic that's called rotational motion. So we have again the next question. This will be question number 4, and a fundamental question. We ask ourselves, what is rotational motion? Right? What is rotational motion? Okay, what is this type of motion? Wow. So we can pause the video, because rotational motion, I showed you one example is just means that the fan blades. That's one of the example. So I have shown you firings of the ballet, slidings of the door, opening and closing the door. So you see that those are the examples. So you know them. Okay, so pause the video, write your definition, and then you can play to check whether you are right or you're not right. So it's a rotational motion. Rotational motion, we say that is a motion, is a motion, the type of motion of a rigid body. This is the motion of the rigid body, right? Motions of the rigid body, which takes place right? Which takes place in such a way that all of its particles, such a way that all of its particles move in cycles. About an axis. With the common angular velocity. Common angular velocity. So the rotation motion is a motion of the rigid body which takes place in such a way that all of its particles move in cycles, okay, about an axis with the common angular velocity. So I don't want to give you another definitions. I know there are so many definitions, but remember that the focus for this topic is motion in a straight line, which is called the translation motion. So I'm just introducing you these other basic types of motion. So you say that, so let me explain. Rotational motion is the motion of a rigid body. So first of all, in order for a body to describe rotational motion, then we say that body should be rigid. Say a rigid body. Okay? A rigid body, for example, a bicycle ring, right? A spherical ball, which takes place in such a way that all of its particles, okay, move in cycles about an axis with a common angular velocity. What does it mean? We say that this rigid body contains particles, right? Call them atoms in chemistry. And if these particles move, right, in cycles about an axis, not in cycles about maybe a path, but in cycles about an axis with a common angular velocity. What it means of common angular velocity? For example, angular velocity means that the velocity of bodies or rigid bodies describe either rotational motion or circular motion, right? While the word commons, it means the same. All the particles should describe or should move in cycles about an axis with a common angular velocity. What does it mean? For instance, you see that, I will give you 3 examples. The first example, suppose that myself, I'm a rigid body, right? I'm a rigid body. And then, because I'm a rigid body, I want to describe a circular motions about an axis. So it means that I'll be rotating myself at this point, and then the axis of rotation will be at the center of my rotations. I can even mean that I'll stretch out my hands like this, right? So it means that Now I'm describing what this is rotational motions. I'm still in the same locations, the same place, right? So this is the circular motion. This is the rotational motion. This is the rotational motion. What an axis, rotational motion. See, then I stand. Also, I can take even this ruler and then still at the same place. So the axis of rotation is here. You see, the axis of rotation is here. So this is this is rotational motion. It's not a circular motion. Circular motion is in case, for instance, that I'm here and then I'm describing a circular motion about a certain cycle, right? Certain cycle with a certain constant radius. That the means of circular motions. It's quite different from what rotational motion. Again, I can do the last demonstration for this rotational motion because I want you to understand when we're studying advanced physics, because you have to keep this information, you will remember, you will be understanding the truth, how the truth is going in physics. So this is the fan right now, right? So this fan is revolving in this direction, right? And then it's just changing the M. So let me just, when it changes there, and then let me stop it. So you see, so this thing is describing rotational motion. So it's rotating in this direction. Where the axis of rotations, this is the axis of rotations here at the center, where there's the axle, right? So this is the axle, because there's the axle, then this is describing what circular motion. No, excuse me, rotational motion. And then you find, for example, how many spades we have there, fan spade. We have 3 fan spades. But all the 3 fan spades, they move with constant angular velocity, right? I believe that you enjoy it. You have to enjoy the beauty of physics, because physics is the study of nature and it's very interesting in the daily life of a human being. So then we have the next question, which is question 5. Question 5. What are the examples? What are the examples? What are the examples of what? What are the examples of rotational motion? Right? Rotation motion. What are examples of rotational motion? Okay? We have so many examples of rotational motion, but thank God I found few of them which are very familiar. You see them every day in your daily life. You can even pause a video and then try to mention examples if you've understood the concept, right? The first example is a motion of a door. So motion of a door, right? Motion of a door. That's the first example. Motion of a door when it is opened or closed. When the door is open, when it is opened, when you open a door or you close a door, that's rotational motion. So when you open a door or when you close the door, that's rotational motion, right? Suppose that this is the door, right? And then see it is closed. So if you want to open to get inside, so it's rotational motion. So it's describing the door will be moving. If it's just like, if it's a non-sliding door, then it's going to move 90 degrees, right? 90 degrees. So we say quarter rotation motion. That's the first example. The second example of rotational motion, we say the spinning of the ball. So I believe that you love football, or you have been watching football, or either live at your school, or you are playing football. Okay? You are playing football, or even that if you are not playing football, so you watch football on TV or online. So spinning of the ball. So the ball that if you kick, it may be spinning. So it might be rotating about an axis with a common angular velocity, and all the particles will be describing a circular motion, right? So this is the second example. The third example, which is familiar with you, motion of a bicycle tire. Motion of a bicycle. Have you ever ridden the bicycle, right? So that motions of the bicycle tire, right? Of motion of the bicycle, okay? Motion of the bicycle, right? Is rotational motion. It's linear itself, the bicycle, so motion of the bicycle tires, okay? And the bicycle tires, even during your childhood, you have been riding a bicycle. So the bicycle tires, when you are riding a bicycle yourself, you might be moving translationally. But the bicycle tires describing rotational motion, not circular motion. Describing rotational motion, you are the one who is a driver who can describe either translational motions when you are riding a bicycle or circular motions when you are making a corner, right? But the bicycle tires, always they are describing circular rotational motion. Bicycle tires, right? We have so many bicycle tires. We have car tires. They describe circular motions. Even also you have motorcycle tires, right? Motorcycle tires in Tanzania, these are famous with the name boda tire. Okay, boda tire. So that is the second example. The first example of rotational motion is motion of the fan, right? Motion of the fan. Okay, motion of the fan's blade. Fan's blades, we call them, those are the ones that rotating I've already demonstrated to you. Okay? Again, another example of rotational motion, so that rotation of the S, right? About its own axis. About its own axis. Its own axis, which takes how long? 24 hours. Identity in geography, that the S can revolve the sun, but also the S has a tendency of rotating about its own axis. The S has a tendency of rotating about its own axis in 24 hours. Okay. Then have the 60 example. The 60 example, we say that revolutions of the S. Revolution of the S? No, that is circular. This is not true. Helicopter rotor blade. Have you ever seen a helicopter? Have you seen that what is rotating above? So that is a helicopter. In physics, we call it a helicopter rotor. Rotor blades. It's just like the fan blades. Helicopter rotor blades, like the fan blades. Then the second example of rotational motion, this is very interesting. It's clock ticking. Say clock ticking. So clock ticking, we say that you have clocks. You have clocks that showing time. Okay, clock ticking, let me just explain. You have clocks that maybe showing times that now it is, let's say, it is 3, it is 4 past 3, possibly PM. But you have also those we call them watches, right? So that you have against a clock, for instance, that this we call T3, this we call T12, this we call T6, if I'm not mistaken, this we call T9, something like that, if I'm not mistaken. Okay? Or even vice versa. I don't remember it clearly. So for instance, you find that one of the click, one of the tickings here, and then you find that the other one is somewhere else there. You say that it's possibly here. So you find that this ticking is rotating, this is called clockwise direction, right? So clockwise direction. So that is rotational, example of rotational motion. So I have mine. Let me show you. Okay? So I think the best way if I show you in this way. Right? So you see? So you see the red one? However, that's still moving in different direction, but you see the tick is what? Is moving. So that's we call T. Those are all examples of what? Rotational motion. Okay? Rotational motion. Do you like rotational motion? Okay. So because we like to have active students, right? Then it's a time now I want to leave the homework for you. This is homework 2, because this is session 2, homework 2. I have 2 questions, right? I have only one question. With the aid of 7 examples. Use the reference books, 7 examples, explain briefly. Use the reference books that we have mentioned to you briefly. The meaning of oscillatory motion. So with aid of 7 examples, mean that explain what the meanings of oscillatory motion are so to be required, and then mention 7 examples of oscillatory motion. You know them. Can I give you one? Let me give you one just like it will encourage you. Have you ever seen the guitar? You know the guitar? Most of the standard guitar, they comprises 6 strings. And then so you find that if a guitarist is plucking to produce a melody or to produce a harmony, right? And then so find those strings are vibrating. So that's one of the example of oscillatory motions. Simply, it's a motion that when a body is describing something, we call it in advanced physics, simple harmonics, executing a to and fro motion. Again, can I give you a second example? Springs. Have you ever seen springs? Yes. Okay. And even springs. So you remember that it's springs. So for example, a spring can be compressed by compressional force and can be stretched by what is stretching force. So that's the example. So it means, for example, if you stretch the string and then release, then to be start executing to and fro motion. That's the means of oscillatory motion. So they are not actually complex because we'll be learning this. There's a special topic of oscillatory motions. You learn it anywhere for advanced physics. And also there's a special topic in mechanics that's called simple harmonic motion. So we should be learning different phenomena describing oscillatory motion. If that's the case now, I would like to thank God because this is the end of session 2 of motion in a straight line, right? But the motion in a straight line. I thank God who have been with me during the preparations of this session, and I thank God who have been with you during the preparations of this session. And I thank God also who is faithful and made these sessions to happen. They had so many challenges. And I'd like to invite you in session 3 of motion, where that I'll do corrections of the format that I gave you, which is oscillatory motion. And also I will teach you about distance and the displacement. So that's the session 3 for motion in a straight line. So I invite you, make sure that you join me. And how you can join me? It means that you have to make sure to subscribe onto our YouTube channels. That's Tanzania Online O-Level Safety School. And in order to get notifications once we upload a new topic, a new session, which is session 3 of motion in a straight line. Again, I insist you to share these contents to millions of your friends, of your classmates in your schools, in your street. Share with them because we would like to see these materials helping millions of Form 2 or Class 10 ordinary secondary school students so that they may solve real life by combining the knowledge that they are getting in class with the knowledge of the Word of God in order to solve complex and even simple problems in the real life. So really, may God bless you. I used to pray for you often, and I ask you also to pray for me. But again, in case that you find that you feel from your heart you want to offer your free will in thanksgiving in order to support the running cost for this program, so that many lectures or many sessions of motion in straight lines or physics form 2 will be in air or will be transmitted to your place, then you may send your free will in thanksgiving offering by using either the mobile phone, so this number 0759745331, you can even do it now, and the confession name is Olenjolai TAYAI. And then once that you receive your transaction message, We'll give you a feedback ourselves with a message to say thank you that your free will Thanksgiving has arrived in our hands, and believe us and believe me that where it's going, it will be used for this purpose and not otherwise. Again, if you want to do the bank transactions or send your free will Thanksgiving offering, you may use the bank transaction. Click the buttons show more in order to get in order to know their bank account, bank names, and even the bank account, so that you may do or you may send your free willing Thanksgiving. So may God bless you. See you in the next session.